Hey there, a warm welcome to one and all for today's Tech Tuesdays webinar on Cloud Data Governance and Catalog Databricks Notebook Case Study. I'm Brinda, your host for today's webinar, and Sachin Jain and Srinivasa Gopal will be joining us as the presenters for this session today. Before we start the session, let's go through some housekeeping tips. The webinar is for 1 hour, that includes a 15 minutes Q&A. You can post your queries in the Q&A box. Dial-in participants are muted for the entire session. The session will be recorded and will be available in the Informatica Support YouTube channel and the Success Portal. You'll be able to download the slide deck from the Success Portal as well. Please feel free to put in your feedbacks and suggestions for the session in the post-webinar survey. The Tech Tuesdays webinars are hosted within the Success Portal, which is a microlearning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. Here are a few important links that you can go over later that will help you in your product adoption journey with Informatica. Over to you, Sachin and Srini. Thank you.
Thank you for the introduction. Here is the agenda for today's webinar. We'll go through overview of cloud data governance and catalog application, Databricks architecture patterns and its integration method with cloud data governance and catalog, Databricks scanners that can be leveraged, metadata that is getting extracted from Databricks environment and its usage, demo and question answers. Let's get started with overview of CDGC. It's a SaaS-based application hosted on Intelligent Data Management Cloud, which is cloud-native, microservices-based, API-driven, elastic, and serverless platform. It can be hosted on Microsoft Azure or AWS or Google Cloud. It coexists with other application or service like Cloud Data Integration, Cloud Data Quality, Cloud Data Marketplace, etc., providing a common user experience to end users. As a SaaS solution, it drives the success of your cloud data lake and data warehouse implementation. Being a cloud native solution, it's low maintenance from a platform perspective with auto upgrade, auto scale, etc. Provides a rich features like data lineage, providing traceability, profiling, data discovery, source context. Other enrichments that can be added are business glossary, providing business context, AI models, data quality, and privacy standards. It is tightly integrated with cloud data quality and provides a business end user navigation experience. Here are the core solution tenets. Being a serverless, it works at any scale. There is no infrastructure to deploy or manage. Multi-cloud, which works across all cloud ecosystems and on-premises data sources. It's an integrated platform with other data management and consumption tools. It's being AI-driven, it uses the machine learning and intelligence to ensure end-user productivity, and it's automated. It's open and extensible platform as it's a API-based access to metadata repository and functions. Let's move on to Databricks architecture patterns. Here is a reference architecture for Databricks Delta Lake with IaaS or IDMC platform. We can see there is on-premise sources as well as cloud sources. Databricks Delta Lake is hosted on the cloud environment. IaaS Cloud Data Integration Service is being leveraged for data movement and push-down optimization into Databricks, which is eventually loading into this analytics or reporting environment. The Secure Agent is being installed on the on-premise and cloud to facilitate the data movement. The Cloud Data Governance and Catalog here is pointed to every hop, including the Databricks Delta Lake, cloud data integration, cloud sources, as well as on-premise sources to get the end-to-end visibility of the data and lineage and profiling stats, etc., to give business complete insights of the data lake environment. Here is another pattern for Azure reference architecture, having a Databricks Delta Lake in the storage layer and transform layer. The ingestion is happening through Azure Data Factory from a file layer and then the relational database layer to the Azure Data Lake Store, which is a raw layer. And the consumption is through Microsoft Power BI reporting. There can be a wide variety of tech stacks or patterns that can be implemented. However, Cloud Data Governance and Catalog can capture on all those layers of metadata and profile stats, providing you complete insights of the data, what is happening, and helps you in making governance-based decisions forward. Here's the similar AWS-based reference architecture, which has a Databricks Delta Lake as well in the storage and transform layer. The ingestion is with Cloud Data Integration, and S3 is being used as a raw layer, and consumption is with Tableau. As I mentioned, there can be a wide variety of patterns that can be implemented with various text stacks. However, Cloud Data Governance and Catalog can be pointed to any of these hops, either with the raw layer or transform or storage layer or consumption layer or with on-premise sources to get the complete visibility of the data inside the AWS landscape over here. Here is a possible way of integration of Cloud Data Governance and Catalog application with your respective cloud ecosystem. Here the reference is taken with the Azure reference architecture. So the secure agent is basically interacting with any of the hops here, like either the raw layer or transform layer and Databricks Delta Lake layer or Power BI layer, and extracting the metadata and profiling stats into the Cloud Data Governance and Catalog repositories. We can see there is various scanners available. It can be discovery service can be used, and it builds inventory, and it can apply security or privacy or classification techniques inside the Cloud Data Governance and Catalog application. Moving on to some of the Databricks scanners that can be leveraged. Databricks Notebook Scanner is one of the important scanners that needs to be used to capture the Python code that is being written in the Databricks environment. Some of the key assets are notebooks, folders, and command level information, which is essentially the metadata type that is being captured. And once the connection assignment is completed in Cloud Data Governance and Catalog, then you can see the lineage also being shown, which is providing you the visibility and traceability of how the data is moving. There is a docs links that has been attached here, which is essentially helping you to setting up the scanner itself with the service account permissions and connection level information before setting up the scanner in the application itself in Metadata Command Center. Similarly, the Databricks Delta Lake Scanner extracts the table level or view level information, and you can also see the profiling stats. That is very important to understand the current state of the data quality, and if there is a need, there is a for data quality rules that needs to be established and monitored on an ongoing basis. Similarly, the docs links has been attached so that you can see what is the prerequisites to set up the scanner. So there are two scanners listed over here. However, like for every hop, as we saw in the architecture diagram, there needs to be a scanner setup and capturing the metadata to get the complete visibility, like Azure Data Lake Store, or whether it's S3 or Power BI or Tableau. Just need to set up the scanners and so that you can capture the metadata and get the visibility. Moving on to the Databricks metadata. Let's go through some of the examples that is being written in the Databricks notebook here, which is essentially the PySpark code, trying to transform the data from the source to the target and cleanse or standardize, etc. You can see some of the code here as an example. Now, although there can be a wide variety of patterns, we have shown some examples over here, which has been written to move the data. It's basically a CSV file being used and into a data frame with attributes that are listed over here, and then loading into the corresponding target. Similarly, you can see the other PySpark code as well, where it is trying to set the context and get all the information from the Azure file system and storage and get the corresponding data and move into the target that is after the transformations being done. This is how you will see after the scanner being completed with successfully, and then the capturing of the metadata over here. You can see the command line and the code that is being written into the cloud data governance and catalog. And here is the lineage information once the connection assignment is complete. You can see the end-to-end lineage. Here is some of the examples. However, you can see in your environment how the data flow is and implement it accordingly. So here is a delta table scan that is being shown here, which is having the Databricks side of delta tables that is being created, and the corresponding scanner results that is shown on the left hand side with Databricks delta lake tables and columns and etc. that can be navigated in cloud data governance and catalog, along with the hierarchy information. Now let's move on to the demo part with Sachin. Handing it over to Sachin. Thank you.
Well, thanks, Srini, for the brief introduction about how our cloud data governance tool will extract Databricks notebooks and also Databricks data tables, and then showcase the complete end-to-end lineage. So let's get into the actual demo. The page which I logged in is actually Databricks. Okay, so I'll show you the sample script which we have for this demo is delta tables. Okay, this is the script name, and it has two commands, command 1 and then command 2. Okay, so what it does is all about initially these are all the configurations for Azure Databricks. Okay, so and then the main thing is the storage layer is like the raw data which is there in the Azure Data Lake ADLS Gen 2. Okay, so from there say mapping.csv and then extracting, and then we have the other two files, like we updated Databricks mapping underscore emp file, as well as Databricks mapping underscore target file actually. Okay, so this is at the raw layer actually. Okay, so the first command will do the extraction of this mappings. Okay, and at the ADLS Gen 2 layer. Okay, the second the command is what it does is the first layer we have this files which is there in the ADLS Gen 2. From there which we extract it. Okay, and then we storing it into our delta tables actually. Okay, so that is the main thing which is the command 2 is actually doing. Okay, so and it is creating say mapping underscore report 1, report 2, report 3 is all like the delta tables which is getting created. Okay, so after this what we have is like see one of this tables, say mapping report 1 or 2 or 3 probably will move to the Power BI report actually. Okay, so this is the end-to-end flow where it starts from ADLS Gen 2 and then it stores in our delta tables, and then finally we are extracting into the Power BI report. So this is the end-to-end lineage we showcase in our catalog now. Okay, so this is the one, and then I'll just showcase that I have already ran this script, and then these are all the delta tables which is created here. Okay, so under this schema. Well, so this is about Databricks and notebook as well as the delta tables. Okay, so let's get into the CDGC Cloud Data Governance rule. This is where I've logged in, and then you could see this sort of chiclets actually. Okay, so administration, metadata command center, data governance, and catalog. So these are all the main things which are required here now. So why administration, right? So uh, uh, let's get into the administration. Yeah. So administration is all about creating some sort of connections, and then you can define your own users and roles, and then specifically for runtime environment. Okay. So connections is like I've created Azure and Databricks connection details here. Okay. So you need to provide your own org ID, cluster ID, where is your Databricks host. Okay. This driver. Okay. This is one of the major thing. Driver is required to extract delta tables actually. Okay. This is about the connection details. Okay. Let's move to the runtime environment. So yeah, this is actually the agent. Okay. So agent is the is playing a very vital role in extracting metadata from your, say, it sits in your local VPN or in your organizations, and then it extracts the metadata and then it sends to our cloud data governance. Okay. So and this is very simple one actually. So we have provided all the steps like how to download it and then how to install it. Okay. So you can download it here. You can generate one token and then you can provide these informations during the installation of our agent. Okay. So yeah, so this is the main thing, administration point of view. Once your administrations are done, so we have to move to the metadata command center. So this metadata command center will provide you to extract the metadata for any resources, right? Say for this demo, let's take out Databricks, the one which we have created, and yeah, and we have a series of things. Okay, so the resources you can extract. Okay, Delta Lake, Databricks Delta Lake is there, Notebook is there, and some of the things like Azure related stuff. Okay, Gen 2, SQL Server, each and everything are there, like Microsoft Power BI for this demo. Okay, so what we have taken is like Azure Delta Lake notebooks as well as the Power BI. Okay, so yeah, this is the one. So Databricks notebook details. Okay, so you need to provide the details and then you need to select the connection which was created in the administration page actually. Okay, so it extract results. I mean the details which you are provided at the administration and then it showcases here actually. Okay, so this is the one connection you need to provide, and in the configuration, what is that metadata needs to be extracted through the agent. So you need to provide the agent which is installed in your org actually. Okay, so and also the workspace. Yeah, so the users with which I showed you, right? So under this we have a notebook. So you have to provide your path here to extract those information. And there is one more option for the filtering point of view. So I would suggest to use the filters, because otherwise if you have n number of notebooks, so that it extracts everything under that particular the workspace, right? So I have provided delta tables as a filter so that it extracts only this notebook. Okay, so after that run, and then yeah, it takes a few minutes to extract it, and then it shows the results in governance too, right? So, and this is the one of the things. So, and what else we have is all about on Power BI, right? So Power BI also has the same details of connections. Okay, so you need to provide all the information about where you are extracting, where is your report sets actually. So you need to provide all the information for to extract metadata, and also as I mentioned, provide the the runtime environment. Okay, so provide all these details and then say run it, extract the metadata. So probably you might be thinking that how does this metadata looks like, right? So as I mentioned, so data governance and catalog is another chiclet. You need to open this one to showcase the metadata extracted through MCC. Okay, so before it loads, let's go to the MCC again, and then probably we'll showcase Databricks data lake, right? So this is for to extract delta tables actually. Okay, so again you need to provide all these configurations. There is a filter, and you need to provide the schema actually. So again, if you have multiple schemas, so better to use this filtering point of view for as best practices. So you can extract delta tables as well. Okay. So as I mentioned, so JDBC driver is very much important here. Okay. Let's move to the catalog page now. Okay. So once the metadata extraction is done, so let's go to the details of the catalogs. Okay, so see, these are all the different stuff, new Databricks notebook is there. Okay, what do we extract from the notebook point of view? Okay, let's concentrate on that point. So what we have is the folder. If you have, yes, we do have, and then the notebook, which is under, that is the delta table. Okay, how many comments are there? Yes, as I showed, we do have 2 comments. Okay, so and the attributes which are used as a calculation point of view. So this is what we extracted. Okay, so yeah, so and again, let's go to the say delta tables. Yeah, so you could see the schema which I was selected was default. Yeah, go to the tables, right? Lakehouse tables, we do have mapping reports, as delta tables which got created. Okay, so and these are the things. Okay, so now what we can do is now see the suppose a business user, he is looking for some sort of a report, right? So the one which we have created is all about the Power BI report. Okay, so let's get started on searching on that particular report, say the Power BI report he is looking for, and yeah, so he got it actually. Okay, so this is what the Power BI report, which has which has a report. So you could see the data set, and also data set. So Power BI has data set as well as the report, right? So let's go to this report. Okay, so now you could see the report in the and also the lineage point of view as well, right? So the data set to the report. Okay, so now let's try to expand. So he could see this, okay, the report and the data set is available, right? So let's try to show all the different hops which are available to the entire lineage point of view, right? So as I mentioned, this report is generated from, say, data lake table. Okay, so now Databricks report, it has a data set. Okay, so and then once he travels back to that, what is the source? What are the different sources which are providing some sort of inputs to this report, right? That is what the main intention he is looking for. Okay, so when he selected this report and then he got the complete lineage of it actually. So you could be wondering that where this lineage came from, right? So again, so if you could see the lineage, it is coming to a delta lake table. So this is the report one, and it has 2 comments where different mapping CSV, EMP file as well as target files are acting together, right? So this is the 2 commands which I showed in our Databricks notebook. So it has the inputs coming from, say, mapping.csv, okay, and then at the raw layer itself is mapping.csv, EMP, and then target. and then finally it is moving to a delta lake table, and then finally it is going to a report, right? So what it does is like, okay, this would be our, the source file, right? This is the mapping.csv. Let's see what information it has. So probably you will see that, from there itself, you could jump into this particular object, okay? And then you could see the lineage as well. All right. So this is how it shows, like, from mapping.csv to the notebooks, and it has at different hops as well. So let's go to the data element level so that you could see the So the attributes or the columns, how the flow is happening, right? So let's try to expand this one. So to see the complete end-to-end lineage at the data element level. Okay, so let's try to visualize this one. So mapping.csv, it has command 1 and command 2, where the script or notebook scripts has, like, these are all the columns which are acted on, and then finally it is moving to a delta lake table, and then it is moving to the Power BI actually. Okay, so he could see the flow which is happening here. Okay, fine. So this is how the business guy who logged in, and then he do the analysis of, like, where and how this report is getting generated, and then what are the sources which are acted on that. Suppose if organization has their multiple sources, probably relational sources as well, which is used in Databricks notebooks, say Oracle or a Redshift, or from the AWS point of view, those informations can be extracted and then showcase, end-to-end lineage here itself. Okay, so yeah. So now, so we have seen, like, how the business user who's looking for a report, and then how does it search, and then you'll see the complete end-to-end lineage. So now, let's go to some of the things in our data catalog. So which shows, like, what all the data you extracted here, right? So let's go to the Databricks notebooks, and then you have a command 2. Suppose if you want to see in the command 1, how does the lineage looks like, right? So which has, like, followed by the command 2 as well. So this is how it looks like, right? The same thing which we have seen, but also you can see it at the command level as well. Okay, so this is the the end-to-end, and then you could see data lake tables, and then finally it is going to a report, right? So major things, like, suppose if you want to see if you could highlight, it shows the where and which command has, the scripts, right? So where it has extracted and then showcase, right? So that is the one. And then yeah, similar way, so we do have this is for Azure Databricks, which I showed now, and then a simple one which I'll showcase for for AWS as well. Okay, so because we do support for Azure as well as the AWS Databricks as well. This is very simple one actually. Okay, so it has a simple command where the mapping.csv get extracted, and then it stores it to another file actually. Okay, so this is all about on the S3 location itself. Okay, this is very simple one. Yeah, so yeah, thanks a lot. Thanks for your time, and then this is how enterprise, specifically cloud data governance, how does it extract the Databricks notebooks, which is a PySpark entire script, all right? So and then it extracts delta tables, and then showcase in end-to-end lineage itself, right? So yeah, Thanks a lot, guys. Thanks for your time.